Let's do problem number 36 on page 228 as an example. Find the absolute maximum and minimum values of each function on the given interval. Then graph the function, identify the points on the graph where the absolute extrema occur, and include their coordinates. So we need to find absolute min, absolute max, and then also think about where they occur on the graph. So we're working on page 228 with problem number 36. And problem number 36 gives us a function f of t equals the absolute value of t minus 5, and then they give us an interval to work with. 4 is less than t is less than or equal to 7. Well, right away, I know I'm guaranteed both an absolute minimum and an absolute maximum by the extreme value theorem. This is the graph of an absolute value function shifted to the right 5 units. And I know the absolute value function is continuous. There's no hop, skips, breaks, or gaps in it. And I know the instructions told me to graph it at the end of the problem. I'm going to go on and graph it now. So I'm going to plot points at both endpoints, and I know if I plug 5 in there, I'll get out 0, and I already have an idea of what this graph looks like. 1, 2, 3, 4, 5. Go over to 4, and I would get out a 1, and at 7, I would get out a 2. And so I'm already absolutely sure about where the min and the max occur, right? There's an absolute min here and an absolute max there. I want to think about the procedure we wrote down at the end of the last video, that I look for my absolute extreme values at my critical points and at the end points. So let's think about taking the derivative of this absolute value function. Well, it's an absolute value function, and I know on the left-hand side of 5, it's always a line going down with a slope of -1, and on the right-hand side, it's a line with a slope of 1. And this would be for any t less than 5, and this would be for any t bigger than 5. Right? And right there, I know at that sharp spot, my derivative doesn't exist. There's no places where my first derivative is equal to 0. The only critical point is at t is equal to 5, where f prime does not exist. So I need to check my function values at the 2 endpoints and at that one critical value. And this example is kind of easy, and we probably could have done it just by graphing it, but I want to show all of my work. And so what I usually do is I like to build a table of values that include the critical points and the endpoints, and I'll just evaluate the function. And this gives me a list of y values. This is the smallest one, so that tells me where the absolute min is. The absolute min of 0 occurs at t equals 5. Right? The min is the y value, but it occurs at the t value. The absolute max of 2 occurs at t equals 7. Again, the max is a y value, but it happens at the spot in the domain. And in this function, the absolute min occurs on the interior at a critical point, and the absolute max happens at a boundary point. And I guess that's it.